everybody, my name is Ralph Rudd, also known as Now We Wake on Twitter and YouTube, and this video is making a third-person shooter prototype in 7 days. I'm using Unity. I've been learning Unity for about the past 2 or 3 months as a quarantine project, and the purpose of this video is really to expose you guys to the YouTubers that you should go look at if you want to build a prototype like I did in a short period of time. So right at the start, what I want to say is, if you don't watch any of the rest of the video, go watch Stevie ROF's third-person shooter tutorial. It's the backbone of the prototype that I did. It contains all the features that I showed in the demo at the start. Go watch his series, it's absolutely excellent. I'll get back to that, but the first thing I just want to run through quickly is the features that got implemented in the prototype over the past 7 days. So this is what we have. We have 4 types of locomotion: crouch, walk, run, and sprint. We have no shooting or weapon switching or reloading while sprinting. We have custom crosshairs while aiming, and the aiming is accomplished using camera blending between 2 Cinemachine cameras, which means that we get things like camera collision detection for free, because it's a Cinemachine component that can just be added to any camera that you're using. I've implemented weapons with muzzle and impact effects. I've got timed weapon switching and timed reloading. Both of them are without animation, but what they mean is that during that time period when you're switching weapons or reloading weapons, you can't fire your weapon or use it in any way. We've implemented damage to destructible objects. Probably the biggest place where I've deviated from Stevie ROF's tutorial series is how he does his weapon aiming. So the way to get the character to aim the weapon, what he does is he changes the character animation by rotating the torso of the character either up or down depending on the mouse vertical location. This is a perfectly okay approach. I do believe, however, that the standard is to do weapon inverse kinematics. And what that means is you aim your weapon first, the weapon of the player, you have the hands attached to the weapon, and then you let the bones of the player sort themselves out using inverse kinematics. I've also implemented, as you saw in the demo, ammo counter, a small HUD, which means that I have a functioning inventory on my character, and he can pick up ammo off the ground. If he picks up all the ammo that's in the stack, then the stack disappears, and the stack can respawn with a respawn time. The last big feature really is how the enemies work. Every enemy is constantly performing a player scan, so every enemy has a defined field of view, right, that he's scanning the whole time to see if he can pick up the player game object. If he does, he checks line of sight by drawing a line, a raycast, from his eyes to where the player game object is that he picked up, technically the player collider, and he checks whether that raycast goes through anything that would block line of sight. That's how he determines whether or not he spots the player. If an enemy spots a player, he changes from whatever his current state is to the hunt state, which is one of the 3 enemy states that I've implemented. In the hunt state, the enemy runs towards the player until the player is within his attack range, which is a value that you set on the game object, and once the player is within his attack range, the enemy will start unloading his weapon. All weapons have a rate of fire, so he can't shoot faster than that, and if he runs out of ammo in his clip, he has to stop and reload, just like the player has to. If the player manages to break line of sight, the enemy will return to whatever state he was in before he spotted the player, which might be idle or it might be patrol. And patrol is a really cool feature that is completely from Stevie ROF's tutorial, and it really looks like this. This is a top view screenshot of the demo that we just saw. The green lines emanating from each of the enemies is their field of view, and the yellow with the little circles is the waypoint system setting their patrol. So the enemies are using a nav mesh to navigate from waypoint to waypoint, and each one can have its own custom waypoint system. And the last thing on the list of enemies that you guys all saw, which is one of the coolest features that you can implement for really easily, is Ragdoll Death. So, what resources did I use to build this third-person shooter prototype in 7 days? Well, these guys. I've said it already, go watch Stevie ROF's tutorial series on third-person shooter. The last video update was in 2018, but I worked through almost the whole thing and it's all very up to date and very, very cool. The big place that I deviated from how he generated his third-person shooter is how I do the weapon aiming. I wanted to use inverse kinematics, so I learned how to do inverse kinematics from these two guys, the Kiwi Coder, who's recently started a series, and Sharp Accent, who probably has more content than anyone else on YouTube available for free of intermediate to advanced Unity tutorials. So definitely go check him out. What the Kiwi Coder does is he shows how to use Unity's animation rigging package, which is a package in the package manager that's still in preview that allows you to set up inverse kinematics inside the inspector. Now, I didn't follow along with that. I tried to do it inside the inspector. I find that setting up complex systems inside the inspector are actually more difficult than just writing code. But I did follow along with these two videos of his that showed me how he thinks about animation rigging. And that's where I got the idea of, first aligning the gun to point in the correct direction. And also, what I think is very cool is I don't parent the weapon to any of the bones, because then, of course, once you parent, you inherit both position and rotation. Instead, the weapon inherits through code the adjustments that the shoulder makes, which was an idea I got from the Kiwi Coder. So the weapon is moving as the shoulder moves, but it doesn't inherit the shoulder's rotation. The weapon's rotation is completely determined by where the crosshair is. And I also followed along with his tutorial on how to use weapon effects. So I basically did exactly what he did to get his impact effects and to get his muzzle flash. Now, to implement the animation rigging, the animation inverse kinematics inside the code, I looked at these two videos from Sharp Accent, Heat Part 3 and Heat Part 4. They're called Part 3 and Part 4 on his YouTube channel. On his website, there are Lesson 5 and Lesson 6 of the multiplayer third-person shooter series. Definitely go check them out. This basically just showed me how to set up inverse kinematics in code. The last resource that I want to point out here is the Renaissance Coders. They've done a series recently, or he's done a series recently on I think it's called Game Dev Essentials, where it's about 5 videos that covers a different topic each time. One of them that I really enjoyed was the Unity 2020 Advanced Audio Manager. It's the audio manager that I've implemented to play that song that you hear right at the start throughout the demo. I haven't yet used it to implement any other sound effects, but I think it's a really good way to organize your sound in code. So those are all the resources I used to build the demo as you saw at the start of the video. Go check them out. All the links are available in the slide pack directly, and you can grab the slide pack from the description. I have 3 quick tips that I want to share with you guys that I learned through this whole process. And the first one is to make the distinction between awake versus start. Now, everyone knows that awake runs before start in Unity, but I've seen a lot of YouTube tutorials on Unity that do different things than awake and start, and it wasn't very clear to me what each of them is for. So let me make it as clear to you as I possibly can. In awake, you initialize the object itself. You self-initialize the object. In awake, you do things like get component or set the members of the game object to values. In start, you do anything that has to connect your game object to other game objects. That all happens in start. And the reason you do this division is so that when you get to start and you have to check, for instance, whether the player has this, or you have to check the ammo container, you know that those things have been initialized because all of them get initialized in awake. Everything gets initialized themselves in awake, and they only speak to each other in start. This really cleaned up my code and helped me avoid the sort of problems you run in when you start to do manual script execution order. Now, these two things by themselves may not be enough. Knowing this distinction may not be enough. You might need something to be ready by the time any of your scripts wake up. How do you deal with that? Well, I got this fantastic answer from Fatty on Stack Overflow. I'm not calling him a fatty, that's his Stack Overflow username. And his answer to this problem is to use a preload scene. Now, a typical answer to the problem of saying, well, I want something to be ready before anything else is ready, is to create a static class, right, that doesn't inherit from a mono behavior so that you can be sure that class is instantiated before the scene loads. The problem with that, with not inheriting from mono behavior, of course there are good use cases for it, but the problem with it, of course, is that you lose all of Unity's flexibility to drag and drop things and connect things in the editor. So I really want a game manager that is a mono behavior, but I want my game manager to be ready before any of my other stuff wakes up, and for that I use a preload scene. I highly recommend you go read this whole question, read the responses to the question. It sorts out the fact that you never need to use a script execution order, and you're only going to use don't delete on load, that functionality on one place. In one place in your preload scene, you're going to make sure that that one game object isn't deleted on load, and all the controllers that you need initialized are all going to sit on that one game object. My last tip is to draw pictures. So when my projects get big, and I mean not even huge, right? Just of moderate complexity, I start to get very anxious and intimidated because I don't know how all the pieces fit together. What's helped me for this project when I got to that point is I started drawing pictures of how the components fit together. Now, I have no formal education in computer science, so I can't draw class diagrams or whatever it is these guys do. All I did was draw pictures of the game objects and the scripts that sit on them. And this really helps me work. So for instance, here I can see that if I have a ranged weapon reloader, it's going to exist only on a ranged weapon game object. And by following the arrow, I can see that a ranged weapon reloader needs a container. It needs an inventory in which to store ammo. I use dotted lines to indicate things that are optional, so it's clear here that the player game object needs a ranged weapon holster, a place for him to store weapons, but the ranged weapon holster doesn't actually need to contain any weapons. So as the project became more complex, I really relied on pictures like this to help me make changes without breaking things that are connected to the object that I want to change. The last thing I just want to do is give a shout out to my two best gamer friends, Toxic Skunk and Flox. These guys listen to me talk every day of the week. I sent them a small update video on what I was busy doing. Sometimes they even watched it in game feedback. But seriously, I'm really grateful for the motivation that they gave me. So that's it. You don't need to like or subscribe. I just hope that this helps someone. If you want to talk to me, you can reach out to me on Twitter. Thanks a lot.